Well, it was raining a little bit today, so I couldn't get too much done with the project. But I want to show you a little something here in the shed. This here is a drill bit gauge. I had this for a few years. I have a metal one around somewhere. They're very hard to read because it's embossed. And you know, the raised numbers in the plastic and the most hardest things to read. But anyways, this is how you measure a drill bit or even a shaft on a motor. Now, I can't get any closer with this camera. It'll go out of focus because I'm using the Kodak ZE-1, and I'd have to go to my standard definition camera and set that on macro. There is no macro feature here. But this is 21/64. I know you can't read that, but that's the opening there. 21/64 is the diameter of this shaft on this motor. It's 21/64. I don't know if you can see that. We'll take it away. I doubt you can see it because I'm about 6 inches away. But anyways, that's the diameter of the shaft, not a 1/4 inch like I thought. Now I'll see if I can locate 3/8, which is, I'm going to have to get my magnifying glass to stop the video a minute here. 3/8 is where my finger is. So 3/8 is a little bit larger. I could wrap a shim around the shaft, like a thin piece of aluminum or something, and then slip whatever I'm going to slip over if I can't get 21/64 for a coupler. Anyways, that's the drill bit gauge. A very handy thing to have. Now another option I was going to do, I got some 1/4 inch threaded rod. I had this, oh heck, they threw it out at work when I was still working. I was going to use threaded rod, but the diameter is a little small, and I'd rather get something, maybe a 3/8 inch threaded rod, and butt it up against this. And instead of using the pulley arrangement, use a threaded rod. Before we get into that, you're probably asking, what did I do with this bottom here? The brushes were exposed on this motor. And to have no damage and dirt getting in there or anything, I wrapped a thin piece of aluminum around, and then I taped it on there to protect the motor. Now, on closer examination, this is a surplus motor, of course. It's been hacked off at the other end here. I just noticed that today when I was looking at it. It doesn't seem to affect the motor any, but it must have had another shaft coming out of the left side of the motor, as well as the right angle coming out on the right side of the motor as you're looking at it. But they hacked it off, and you can see blade marks where they actually did it. I don't know if it'll show up under the light in the shed here. But anyways, that's interesting. But it's a high quality motor made by Johnson. So I had some scrap aluminum, real thin aluminum, and I just simply cut a 1 inch wide piece, wrapped it around the motor on the openings where the brushes were, so no dirt will get in there and crap will get in there and jam it up and screw up the motor. I have plenty of this stuff. I have a whole bunch of aluminum here, and this is galvanized over here, and these are big mending plates. These are things I pick up at the yard sale from time to time. Now, of course, I still have to upload part 1 that I keep promising to do, and I haven't done it yet. But anyways, may not use this homemade pulley arrangement if I use a threaded rod. We're just talking theory here as to how these things can operate. And I don't have my tripod here, so I can't demonstrate. Now, let me just hold this copper tubing onto the shaft. Now, if you visualize the shaft or the head stick is only going to turn 180 degrees. That's all anybody can turn their head, is probably 180 degrees, if even that. So it'll go like this, it'll swing around and go this way. So I'm holding the camera, so you're going to have to kind of like visualize what I'm trying to say. When you use a threaded rod, like I want to do, instead of the pulley arrangement, because the other problem, I can't seem to locate a round, quarter-inch round belt. That I can't. They don't seem to have them, and I probably got to go hunting on the internet for it. And I have bad luck trying to find things on the internet. So let me show you here. I'm going to do it on the floor here. Okay. All right. We union these two up. Naturally, I'm going to use 3/8 rod. That's as close as I can come to 21/64 on the shaft here. So I'm going to butt these two up using not this threaded rod, but a thicker one. Now, visualize that head stick that I just showed you. The rod and the motor will be fixed position. The motor will turn the rod either left or right, depending on my switch arrangement to go in reverse, which I've already had that worked out. That's no problem whatsoever, just buying the switches for it. But anyways, this is the head stick here. This is the rod coming out, and on the end of the rod is going to be a nut. Now, there's going to be X number, don't ask me to do math because I'm no good at it, so I just do everything by trial and error. When the stick is turning over here like that, you need more length. So in other words, the nut that's going to be on the end, one of these nuts here, only a larger one if I can get one, or make something up, is not only got to slide up and down on this. Actually, the rod will probably slide in and out like this in order to follow along as it's turning in the radius, the half radius. But it's also got a swivel. The nut has to turn. Like if you're going 90 degrees here, you're going probably 45 degrees over here at the extreme, let's say. Well, the nut has to turn 45. So here's my finger there. But when it arrives here, the nut is going to be straight. So if I can get that worked out, and it takes a lot of precision work to drill a hole in the nut to have a swivel pin going halfway through the nut. What I will probably do instead is take my tap and die set. I've also got taps in here. Get a block of aluminum, which I'd have to buy, and thread it. Make my own nut. That way it'd be bigger and easier to work with. I just happened to run across this. I bought this at a yard sale last year for about 50 cents. It's a right angle drill adapter, which you can put a coupler on. I'm going to make my own couplers because I want to thank everybody for directing me to these places where they have couplers and so forth, but it's impossible to find these things unless you give me a direct link to it. So what I want to do, here's a better explanation. Just pretend this is a half-inch bolt, by the way, but I'm just going to use it as a demo. You see how large the nut is for this? Well, it's not big enough for me to make a little hole here and a little hole here so I can make the nuts swivel. The nut has to be able to move. You can't just put a nut on a threaded rod and expect to turn because it'll jam up. The nut has to follow the angle, if you get my drift. So I have things I got to work out, and it's going to take a while. But I appreciate the links and so forth, the information to these different sites. But I don't have much luck trying to find things on the internet. It's very vague. It's hard to locate things. Unless you give me a direct link to a certain item, not just the place where it is, but the actual item itself. But, you know, I can just as easily make the union up. I've got the tap and die set. somebody said to just tap it out and use a piece of brass tubing. Well, I can't find brass tubing around here. So the nearest thing I can do is get copper tubing, which isn't really going to be very strong. But the other idea somebody suggested, which will now work if I don't use the pulley because I don't have any lateral pressure, in other words side-to-side movement, is I could use a piece of hose or something to make the union out of that, because all it is turning the threaded rod this way. If I was going to use the pulley like this, you got a belt on this where my thumb is, and it's going to be pulling. So you got what they call lateral pressure, lateral movement. If I'm using the threaded rod to go directly on here, then you've only got the twisting action, and if you get a heavy enough piece of tubing, you can clamp that on with hose clamps. So that, yes, I have thought of doing that. So that's why I'm thinking of maybe not using this and maybe actually going with the threaded rod idea. The best kind of an arrangement would be an Acme thread. An Acme thread is a much coarser thread, and it's perfect for this sort of thing. But then I got to hunt around for a matching gear to go with it. It gets too involved and too expensive. Threaded rod, regular steel, not stainless steel, is all you really need. But you want to get a coarse thread, not a fine thread, and probably 3/8 of an inch so it will match close enough to this, what did I say, 21/64 of an inch as possible, so that the coupling won't have too much difference in going from one to the other. So that's where we're at right now with this project. It's been raining today a little bit, so I didn't do anything on the project today. I'm not going to keep you waiting too much longer. The next video that I'll be putting up here is going to be part 1 of motorizing my uncle. That's the name of the video. And in that particular part 1, I had mentioned that I did not get the motor yet. Well, obviously the video was made before I got the motor. Well, I think that's about it. The next video will be part 1 of motorizing my uncle. Now that video series for the project is not going to be going up as often maybe as building Uncle Dorkle, because it's going to be maybe a week or so before I get the next one up. It all depends on how the weather holds out, and it all depends on a lot of factors. If I get all the materials that I need to complete this project. So it may go up bang bang bang, it might go up brrr, brrr, brrr. It all depends, folks. Stay tuned. What are you doing up there on the top of the shed? Huh? Yeah, what are you doing up there, Sammy? Huh? Hey, what's going on, huh?